In this example, we're asked to write the rule for the inverse. That's just another way of saying write the equation of the inverse. So let's start with that. We have our equation here that f of x in front is really just a fancy y equals. And when you come up with your equation for your inverse, you simply replace all of the y's in your equation with an x and all of the x's with a y. And then we should take that inverse equation and we should put that into a y equals form. So we want to solve this equation for y. If you take a look at where the y is right now, it is up in the exponent. That tells me that in order for me to solve this for y, to get this out of the exponent, I'm going to need to put this into log form. To take an equation that's in exponential form like this one is and put that into log form, first I want to identify the exponent and its base. The exponent here is y plus 5. The base is always directly below and to the left, which in this problem is an e. The 3 that is here is not part of the base. It would have to be in parentheses with the e in order for the 3 to be part of the base. So we have 3 times e raised to the y plus 5 power. The base is the e. In order for us to put this into log form, we do need to get the base and its exponent all by itself, so we do need to move the 3 over to the other side first. Dividing both sides by 3, that gives me x over 3 is equal to e raised to the y plus 5 power, and now I have the base and the exponent all by itself over on the left-hand side. How we go about changing this from exponential form into log form is by using one of our properties of logs. And that property looks like this. If you have the base of your log and the base of your exponent match, the base of the log and the base of the exponent with the log, all of this right here, all of that cancels out, and instead of having log base b of b to the x power, that simplifies just to x. So this is typically how that property is written. I have in this problem e to the y plus 5 power. That's like this b to the x. So what I'd like to have in front of it is a log with the same base. So I'm going to copy this down again here, but I am going to leave a little bit of space in front of each one of these. And what I would like to do on both sides of our equal sign is do a log. And I can choose any base that I want. I'm going to choose a base of our log that matches the base of the exponent, and the base of the exponent here is e. So I'm going to be doing log base e on both sides. Now log base e, that is the same as the natural log. So instead of log base e, you could write that as the natural log. So the left side becomes the natural log of x over 3. And then our right side, we have the log base e of e raised to the y plus 5 power. And that fits the pattern of our property here. We have log base e, so the base of the log is e, and also the base of the exponent is e. So all of this is going to cancel out. And just like we have here, the exponent becomes the simplified answer. So this is going to be equal to the exponent, which is a y plus 5. And now instead of having our y up in the exponent, we now have it down as part of the regular part of the problem. Solving this for y, we do have one more step. I do need to subtract 5 on both sides, then I will have the y all by itself. So the natural log of x over 3 minus 5 is what y is equal to. We do have some special notation for the inverse, the y that's there. The original function was function f, so I'm going to use that name again, and the inverse can be written that way. So the first part of the directions on this problem said to go through and to write the rule for the inverse. That's the same as write the equation for the inverse. So that is our answer for the first part of the directions. The second part of the directions ask us to state the domain and the range. You can do that a couple of different ways. Here's what I'm going to do. I'm going to take a look at the graph of function f. And I'm going to write down the domain and the range looking at the graph. There's more than one way to go through and do this, but that's how I'm going to start this. So let me take our original equation here. It is 3e raised to the x plus 5 power. And I'm going to hit the graph button and take a look at the graph. This is an exponential, so this graph I know based on characteristics of exponentials. This graph does go forever to the right and continue going upward, and as it goes up, it's going to continue going to the right and up, right and up, right and up. So it goes to the right for forever and up for forever. And on the other side of our graph, this graph is going to get closer and closer and closer to an asymptote, which is right on the x-axis right now. So this graph goes down and then continues over to the left for forever, just barely above the x-axis. So the domain, how far to the left and how far to the right does that graph go? Well, that graph goes forever to the left and forever to the right. The range, what do those y values do? Well, the height of our graph goes up for forever, and it gets down and gets very, very close to the x-axis. It gets very, very close to a height of 0. If it hit the x-axis, it would have a height of 0, but it's just going to keep getting closer and closer and closer. So our value for our range are all of our y values that are greater than 0. If you wanted to put that into set builder notation, we would do y with a vertical line, then do our inequality, and then close that off. So the directions were not to state the domain and range of the original, but of the inverse. So how does that work? Well, it's pretty easy once you've listed out the domain and the range of the original. Because when you go through and you calculate an inverse, you take the x's and replace them with y's, and y's replace them with x's. So your x values, your domain, that just becomes your range when you do the inverse. And your range just becomes the domain. And that is what the domain is of our inverse function.